Hello and welcome to Maths by SAS. This is my first lesson of D3, chapter number 3, exercise 3B, that is about solving linear inequalities. In this lesson, I will solve question number 3, basic level. Question says, find the range values of x which satisfies the given inequalities. If you find any difficulty about understanding of what is the meaning of term solution of linear inequalities, how to solve the linear inequalities, and what are the different types of numbers like integers, rational numbers, and prime numbers, you have to watch the previous lesson, for which I'll give the link in the description box, because for the better understanding of lessons of mathematics, it's really important to integrate the lesson with the previous lesson. Let's move to the first part of the question that says x minus 4 is less than equal to 3 and 3x is greater than equal to minus x. Let's move to the solution of the question. The solution of linear inequalities is similar to the solution of simple linear equations. First, what we have to do, we have to shift this 4 to other side, and when I will be shifting 4 to other side, this 4 has a negative sign towards this side, so it will become positive. X less than equal to 4 plus 3, or x less than equal to 7, and what I have to do, this 3 is multiplied with this x, so when I will be shifting this 3 to other side, 6 by 3, and x is greater than equal to minus 2. The question says I have to write the range of the values. So what we have to do, we have to write the variable at the middle place, and we have to write it x greater than equal to minus 2 but less than equal to 7. So this is the range of the values of x which satisfies these given simultaneous linear inequalities. Let's move to the second part of the question, that is 2x minus 5 is greater than 2x plus 5 is less than 15. It's just less than 15. It's not less than equal to, it's less than 15. And 3x minus 2 is greater than minus 6. Okay, so in order to solve these simultaneous equations, first of all, what I have to do, I have to take this part of the question, 2x plus 5 is less than 15 plus 5 is less than 15, shift 5 to other side and change the sign. 2x is less than 15 minus 5, or 2x is less than 15 minus 5 is 10, or x is less than 10 upon 2, which is equal to 5. And then I have to solve the other part of the question as well. And 3x minus 2, 3x minus 2 is greater than minus 6. Shift this minus 2 to other side by changing the sign, and the inequality will take the form 3x and 3x is greater than minus 6 plus 2, and 3x is greater than minus 4, or what we can do, x is greater than minus 4 by 3, which is equal to minus 1.33. so the range values of x will be x greater than minus 4 by 3 but less than 5. This will be the range values of x. Let's move to the next question. And the next question is question number 4. Question says, find the integer values of x which satisfy 5x minus 1 is less than 4 and 3x plus 5 is greater than equal to x plus 1. So in order to get the integer values, first of all, we have to solve the given inequalities. And we can see the first part is 5x minus 1 is less than 4. In order to solve the inequality, shift this 1 to other side and it will take the form 5x is less than 4 plus 1 or 5x is less than 5, or this 5 is multiplied by x. So in order to get value of x, I have to divide or shift that 5 to other side. X is less than 5 upon 5, or x is less than 1. I have to solve the other part of the question as well. And now, if you look at the question carefully, we can see that the letter that we want to make the subject of formula is on both sides. So it's better to shift all like terms on the same side. 3x minus x will be greater than equal to 1 minus 5. Now, 2x is greater than equal to 1 minus 5 is minus 4. Again, this 2 is multiplied by x, shifted to other side by dividing. X is greater than equal to minus 4 by 2, and x is greater than equal to minus 2. So if we want to write the interval that should satisfy both the inequalities, so x is greater than equal to minus 2 but less than 1. As we need to write the integer values of x, so x can take the value minus 2, minus 1 and 0, because 1 is not included in the answer. So these are the integer values which will satisfy these two inequalities. Let's move to the next part of the question, that says question number 4, B part, 2x minus 5 is greater than equal to 1 and 3x minus 1 is less than equal to 26. In order to find the integer values of x which satisfy both the inequalities, we first have to solve both the inequalities. If we look at the first inequality, we can see this 5 is on the left hand side, we have to shift it to other side. So my inequality will take the form 2x minus 5 is greater than equal to 1, or 2x is greater than equal to 1 plus 5, or 2x is greater than equal to 6, and this 2 is multiplied by 6x. So shift it to other side and it will take the form x is greater than equal to 6 by 2, or x is greater than equal to 3. Coming to the second part, that says 3x minus 1 is less than equal to 26. First shift 1 to other side, it will take the form 3x is less than equal to 1 plus 26, and 3x is less than equal to 27. Again, in order to get value of x, shift this 3 to other side and divide 27 by 3. You should have the command on basic algebra to get the better result. X is less than equal to 27 divided by 3, and x is less than equal to 9. So we have to write the range values first. X is greater than equal to 3 but less than equal to 9. So the integer values of x which satisfy both of the inequalities will be x equals to 3, 4, 5, 6, 7, 8 and 9. I hope you are clear about this question. Let's move to question number 11 of the exercise. Question says an integer x is such that x plus 2 is less than 5 multiplied by under root 17 is less than x plus 3. State the value of x. So in order to solve this inequality and in order to get the value of x, we have to first divide the given inequalities in two parts. So I can write it in this form. So what we can do, that x plus 2 is less than 5 into under root 17, and 5 under root 17 is less than x plus 3. Now, as under root 17 is the square root of prime number, so we have to get the answer with the help of calculator. Square root 17 can give me 4.12 multiplied by 5, that is 20.61. So the inequality expression will take the form x plus 2 is less than 5 multiplied by under root 17 gives me the answer 20.615, that is 20.62, and 20.62 is less than x plus 3. Now what I have to do in order to solve this inequality, I have to shift this 2 to other side by changing the sign, and the expression will take the form x less than 20.62 minus 2, x less than 18.62, and now what I have to do, I have to shift this 3 to other side by changing the sign. Shift 3 to other side, this will take the form 20.62 minus 3 is less than x, or x is greater than 20.62 minus 3, that will be 17.63, and now I have to write the range values of x. X is greater than 17.63, x is greater than 17.63 but less than 18.62, and the question says that x is integer, so integers cannot be in decimal. So the integer which is greater than 17.63 but less than 18.62, so x will be equal to 18. That is the answer for this question. I hope you are clear about this question. Let's move to the next question. Question says, given that x is a prime number, find the value of x for which 3x minus 2 is greater than equal to 10 and which is greater than equal to x plus 4. In order to solve and in order to get the prime number which can satisfy these two inequalities, first of all we have to divide the inequality in two parts, that 3x minus 2 is greater than equal to 10 and 10 is greater than equal to x plus 4. Now first shift 2 to other side, it will take the form 3x is greater than equal to 10 plus 2, or 3x is greater than equal to 12. Now you can see that this x is multiplied by 3, so I have to shift it to other side, means I have to divide 12 by 3. X is greater than equal to 12 upon 3, or x is greater than equal to 4. Coming to the second part of the inequality, shift this 4 to other side, that is 10 minus 4. Shift 4 to other side, 10 minus 4 is greater than x, or x is 6. X is less than equal to 6 and x is less than equal to 6. So first of all I have to write the range values of x. X is greater than equal to 4 but less than equal to 6. I have to state the value of x for which x is the prime number. So between 4 and 6, the prime number which can satisfy both the inequalities is x equals to 5. I hope you are clear about this question. Let's move to the next question. The next question says that solve each of the following inequalities. 3 minus a is less than equal to a minus 4 is less than equal to 9 minus 2a. First of all, decompose and write the inequality in two parts. So what I can do is that 3 minus a is less than equal to 3 minus a is less than equal to a minus 4, and a minus 4 is less than equal to 9 minus 2a. Now I have to solve each part separately. If we look at the question, we can see the letter that we want to make the subject of formula is on both sides. So shift it preferably on the left hand side. Minus a is less than equal to minus 4. Shift 3 to other side. Minus 7 minus 2a is less than equal to minus 7. Now I have to shift this minus 2 to other side because this is multiplied by a. And do not forget that whenever we are multiplying any inequality by minus sign, we have to reverse the direction of that inequality, that is minus 7 divided by minus 2, and a is greater than equal to 7 by 2 or 3.5. And now again, a that we want to make the subject of formula is on both sides, so shift it on the same side. A plus 2a is less than equal to 9 plus 4, and 3a is less than equal to 13, and a is less than equal to 13 by 3. 13 by 3 can take the form 13 divided by 3, that is 3 4s are 12, minus 1. A is less than equal to 4 whole 1 by 3. So I have to write the expression in form of the range values, that a is greater than equal to 7 by 2, that is 3 whole 1 by 2, but less than equal to 4 whole 1 by 3. I hope you are clear about this lesson. For next difficulty level, please catch me in the next class. Watch my lesson, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.